On February 15, 2013, the people of Chelyabinsk, Russia, looked up and saw the sky split open. A 20-meter asteroid, traveling at 19 kilometers per second, exploded in the atmosphere with the force of 30 Hiroshima bombs. Over 1,500 people were injured, and here's the terrifying part. No one saw it coming. Not NASA, not any space agency on Earth. It came from the direction of the sun, our blind spot. This is the story of the asteroids we should actually worry about and what humanity is finally doing about it. Earth is not a safe haven floating peacefully through space. It's a target in a cosmic shooting gallery. Right now, there are over 2,300 potentially hazardous asteroids tracked by NASA. Objects larger than 140 meters that could devastate an entire region or trigger global catastrophe. But here's the problem. We've only found about 40% of them. The rest are out there, invisible, waiting. And it's not just the big ones. Every single day, about 100 tons of space debris enters Earth's atmosphere. Most of it burns up harmlessly. But every few decades, something bigger gets through. Scientists estimate that a Chelyabinsk-sized event happens roughly every 50 to 100 years. A city-killer asteroid, around 140 meters, strikes about once every 10,000 years. And a civilization-ending impact, like the one that killed the dinosaurs, happens roughly every 100 million years. The question isn't if another major impact will happen. It's when. But here's where the story gets hopeful. In September 2022, NASA did something unprecedented. They crashed a spacecraft into an asteroid on purpose. The mission was called DART, the Double Asteroid Redirection Test. The target was Dimorphos, a small moon orbiting a larger asteroid called Didymos. DART hit Dimorphos at 6.6 kilometers per second. And it worked. The impact changed Dimorphos's orbit by 33 minutes, far more than the expected 10 minutes. For the first time in history, humanity intentionally altered the trajectory of a celestial body. We proved that we can fight back. But the story got even more interesting. Recent analysis revealed something unexpected. When DART hit Dimorphos, the asteroid didn't just get pushed. It was reshaped. The impact created so much debris that the recoil effect was 3.6 times greater than the impact alone. Dimorphos behaved less like a solid rock and more like a loose pile of rubble held together by gravity. This changes everything we thought we knew about asteroid deflection. Some asteroids might be easier to deflect than expected. Others might be harder. We need to understand each one individually. That's why ESA's Hera mission is on its way right now. Launching in 2024 and arriving in 2026, Hera will study the aftermath of DART in unprecedented detail. It will map the crater, measure the mass, and help us understand exactly what happened when we punched an asteroid. But there's one asteroid that keeps scientists up at night. His name is Apophis, the Egyptian god of chaos. When it was discovered in 2004, initial calculations gave it a 2.7% chance of hitting Earth in 2029. That's the highest impact probability ever recorded for an asteroid of its size. Apophis is 370 meters wide. If it hit Earth, it would release energy equivalent to 1,200 megatons of TNT, enough to destroy a country. The good news? After more observations, scientists ruled out an impact in 2029. But on April 13, 2029, Apophis will pass closer to Earth than our own communication satellites. Just 31,000 kilometers away, you'll be able to see it with the naked eye, a point of light moving across the sky. And here's what's concerning. That close flyby will change Apophis's orbit in ways that are hard to predict. There's still a small chance it could be nudged onto a collision course for a future return. We're watching it very, very carefully. The future of planetary defense is about to get a major upgrade. In 2027, NASA will launch NEO Surveyor, a space telescope designed specifically to hunt for near-Earth objects. Operating in infrared, it will be able to spot dark asteroids that are invisible to ground-based telescopes. The goal is to find 90% of all potentially hazardous asteroids within a decade. We're also developing new deflection technologies. Beyond kinetic impactors like DART, scientists are exploring gravity tractors, spacecraft that hover near an asteroid and slowly tug it off course using gravitational attraction. There's also the ion beam deflection concept, using a spacecraft's thruster to push an asteroid over time. And yes, nuclear options are on the table for the largest, most dangerous threats. 66 million years ago, the dinosaurs looked up at the sky and saw their extinction coming. They had no technology, no space program, no choice. We are different. We have telescopes scanning the heavens. We have spacecraft that can intercept threats. We have the knowledge and the will to protect our planet. The asteroids are still out there. They always will be. But for the first time in Earth's 4.5 billion year history, there's a species that can see them coming and do something about it. The question is, will we be ready?